Yeah, Assalamualaikum warahmatullahi wabarakatuh. Firstly, let me introduce myself. My name is Abdul Malik Fajaptura Shamsi. I am a student majoring in computer science in the University of Lambung Mangkurat. So today I am going to present my material on cloud-based quantum computing for a form to fulfill an assignment from my English class. Let's get started. Firstly, what is cloud computing? So cloud computing is not referring to something in the sky. No, it is a technology that allows you to use computing services such as servers, storage, database, software, hardware, etc. over the internet while not having it physically. Cloud computing is essentially renting computing services over the internet. For example, Google Drive is a software as a service that lets users store, access, and share files online using Google's cloud-based software without needing to install or manage any infrastructure at all. And then there's Amazon Web Services, which is a interface as a service that provides virtual servers, storage, and networking resources over the internet, allowing users to run and manage applications without owning physical hardware. And then there's Xbox Cloud Gaming, which is a gaming as a service. Uh, in this sense, it is a platform that streams games from the cloud, letting users play high quality games on various devices without needing a console or powerful hardware. Next is, what is quantum computing? So quantum computing is a new type of computing that uses the principles of quantum physics to process information in a fundamentally different way than the traditional computers. While traditional computing uses bits, ones, and zeros, quantum computing uses qubits, which can be ones and zeros or both at the same time. The state in which qubits became both ones and zeros at the same time is called superposition. And then there's also entanglement, which is when qubits can be connected in such a way that the state of one affects the other instantly. There's also interference, which is used to amplify correct results and cancel out wrong ones. Now to the main course, what is cloud-based quantum computing? So it is cloud-based quantum computing, which is a quantum computing as a service, or QCAAS, is a service that provides cloud-based access to quantum processors, simulators, and development tools. In other words, QCAAS let developers, researchers, and enterprises run quantum programs over the internet instead of owning and maintaining an expensive real quantum computer. Now, here's how cloud-based quantum computers operate loosely. I'll explain it loosely because I'm not really deep into this material. So, cloud-based quantum computing combines specialized quantum hardware, programming tools, and internet connectivity to provide remote access to quantum processors. These processors use various technologies such as superconducting circuits, trapped ions, or photonic systems to represent qubits. Because qubits are extremely sensitive to environmental factors, quantum systems require controlled environments like near absolute zero temperature or vacuum chamber to function reliably. Users interact with these quantum systems through cloud platforms using quantum programming languages like Qiskit, Tversky, Racket, or Q-Sharp. Developers can first test their algorithms on quantum simulators, which emulate quantum behavior on classical computers to reduce cost and debugging time. Once ready, the quantum circuits are submitted via APIs, SDKs, or web interfaces to be executed on real quantum hardware. These services are offered on an on-demand basis, meaning users pay only for the quantum processing time they use. And then here are 4 advantages of using cloud-based quantum computing. The first is cost efficiency. which has two main points. The first one is no need for expensive hardware. That is self-explanatory. You can just rent an existing quantum hardware without buying that expensive quantum hardware. And then the second point is play as you go model. It providers usually offers a flexible pricing based on the usage. And then there's scalability, which has also 2 points. The first is access to multiple processors. This means providers provide a variety of quantum processors with different capabilities, from small scale with a few qubits to a more large scale with many qubits. And then there's seamless upgrade. So as quantum computing technology evolves, the providers can offer the latest advancements without users having to replace their own equipment. And then there's accessibility, which also has two main points. The first one is global access, accessible to anyone, making the need for physical proximity to a physical quantum machine useless. And then the second point, which is user-friendly interfaces. So the providers often provides intuitive programming environments and APIs, making it easier for developers to experiment with quantum algorithms. And lastly, collaborative and remote work. There are also 2 points to this. The first one, which collaboration. It allows anyone to collaborate remotely from anywhere and anytime around the world. Might that be working together or on the same platform or sharing results? And there's also remote access to the hardware. Uh, Basically, users can run quantum simulations and experiments on real quantum processors remotely, enabling research and development without the need for a specialized on-site facilities. Now, here comes the challenges of cloud-based quantum computing. The first is it is still in early development. Despite interest keeps going up and up, it keeps growing. Cloud-based quantum computing remains experimental, with most algorithms still in theoretical or proof of concept stages, and few showing clear advantages over classical methods. The technology also demands specialized knowledge, making it difficult for non-experts to use effectively. While progress is ongoing, widespread commercial adoption is likely still years away. There's also limitations on quantum hardware. So cloud-based quantum computing faces significant challenges due to the early stage nature of quantum hardware, which suffers from short coherence time, high error rate, and limited qubit connectivity. These issues, along with the need for extreme operating conditions, like near absolute zero temperatures, make complex computations unreliable. As a result, most current cloud-based quantum platforms use hybrid models, where classical computers handle the majority of processing tasks. And then there's the companies who provide a cloud-based quantum computing. The providers. The first one is IBM with the IBM Q experience. Uh, it gives you free cloud access to real quantum processors and simulators. You'll also be using Qiskit SDK for quantum programming using Python. You will also be given Quantum Composer, which is a drag and drop visual circuit builder, access to superconducting qubit devices, and it offers public and premium plans for more powerful devices, and also educational tools, tutorials, and community resources. The next one is Google Quantum AI, which gives you more focus on quantum supremacy research. And then it also uses TRQ an open source Python library for NISQ programming. It also gives you quantum processors based on superconducting qubits, a tight integration with Google Cloud Infrastructure, but it is mostly research focused, limited to it's a limit. There's a limit for public access compared to IBM. There's also Amazon Braket as a service from Amazon Web Service. It gives you access to multiple quantum hardware providers, IonQ, Rigetti, Oxford Quantum, etc. It also supports both gate-based and quantum annealing via D-Wave. It also uses Braket SDK as the programming language. It derives from Python. It also gives you hybrid classical quantum workflows using AWS tools. There's also a pay-as-you-go pricing model. And then lastly, it is Azure Quantum from Microsoft. This one supports multiple hardware providers like IonQ, Quantin, and Rigetti. It also uses Q#, Microsoft's quantum programming language. It also integrates with Visual Studio Code, Azure Notebooks, and Python. It also offers resource estimation tools for quantum algorithms, and then includes quantum-inspired optimization for classical problems. And also, it is a part of the broader Azure cloud ecosystem. So that might be the end of my presentation. I do hope it gives you a picture on how cloud-based quantum computing should work, should develop, and should be uh, a point to the future. I think that will be it. I am very, very sorry if I have wronged myself and you, the viewer, in any way, shape, or form that I did. I think that is it. Wassalamualaikum warahmatullahi wabarakatuh. Thank you for watching.